Now let's look at some examples about the inverse sine function. Let's try to find the values, exact value of the inverse sine of negative 1/2. What is angle whose sine is equal to negative 1/2? What angle? Negative what? Pi over 6. Right? So, since you know the sine of negative pi over 6 is equal to negative sine of the pi over 6, right? Because the sine of the sine in the quotient 4 is negative, right? This negative pi over 6 is in the quotient 4. So by the reference angle and the sine, we get the value of the sine of the negative pi over 6. So this guy is equal to negative 1/2. And you need to remember the range of the inverse, okay, the range and the domain of the inverse sine function. The domain of the sine inverse is between the negative 1 to 1, right? And the range of this sine inverse is from the negative 1/2 pi to 1/2 pi. So now this negative pi over 6 is the angle whose sine is equal to negative 1/2, and this angle is also in the range of this sine, of this inverse sine. So that is the angle, okay, of this inverse sine of the negative 1/2. Now let's look at another one. Arc sine of the root of 3 over 2. What is angle for this arc sine of the root of 3 over 2? $60, right? So 60 degrees. Okay. Or you may write the as the pi over 3. Now let's look at the inverse sine of the negative root of 2 over 2. What is angle? Negative pi over 4, right? Negative pi over 4. Then inverse sine of the negative root of 3 over 2 equal to what? What is angle? Negative, you can look at this, right? So it's the negative pi over 3. Okay. So this is, okay, these are some examples about the inverse sine function. Now let's continue to talk about the inverse cosine function. And as in the case of the sine function, cosine function is not a one-to-one function, and it's a sine wave, right? If you draw some line, some horizontal line between the -1 and the 1, this line intersects the graph of the cosine function at more than one place. So this cosine function is not a one-to-one function. But we can restrict the cosine function to some interval so that this restriction is a one-to-one function. Now you look at the graph, okay, this part of the graph of the cosine, and we restrict the cosine function to 0 to pi, okay, from the 0 to pi. Then this restriction, this graph is like this, then this restriction is a one-to-one function, and then we can define its inverse function. So this inverse function is called the inverse cosine, is denoted by this, okay, inverse cosine of x. And the domain of this restriction is the 0 to pi, right? And the range of this restriction is from the -1 to 1. Then the inverse cosine function is domain which is equal to the range of this ranging function. So that is the its domain is equal to the interval from the -1 to 1. And you look at it here. So this red one, this is a graph of the inverse cosine function, which is the reflection of the graph of the original cosine function. This green one, this graph of the cosine function. This red one, this is the graph of the inverse cosine function, which is the reflection of this green one about the line y equal to x. And from this red graph, you can see its domain is from the -1 to 1. The range is from the 0 to pi. So now you can see the range of the inverse cosine function is quite different from the range of the inverse sine function. What is the range of the inverse sine function? See here, right? The range of the inverse sine function is from the -half pi to half pi, right? But for the cosine, the range of the inverse cosine function is from the 0 to pi. So this is a big difference. Domain of the y equal to inverse cosine x is the closed interval from 1 to 1. Okay, this is same as the domain of the inverse sine function. But the range of this inverse cosine function is from the 0 to pi. Okay, because we restrict the cosine function to this closed interval. So we may also use the arc cosine for this inverse cosine function.